Factor the given polynomial into linear factors given 1, 0. Okay, well, if we know 1, 0 already, and we have a cubic, we can find the others pretty easily by factoring out the 0 that's known, and then solving the remaining polynomial as a quadratic, which probably just means factoring or using the quadratic formula. So to factor out this 0, we'll use synthetic division. So 2, -3, -17, and 30. So if I bring the 2 down, 2 times 2 is 4. This column adds up to 1. 2 times 1 is 2, so this becomes -15. 2 times -15 is -30, and the sum of this last column is 0, which is good because we said it was a factor. All right, now these values make up the coefficients of a polynomial that's 1 degree less than the original. So that means I have a quadratic. So this is 2x squared plus x minus 15. And if I want to get the remaining zeros, I can do that by factoring. And in fact, I don't really need to get the zeros, I just need to factor it, because it does say to just factor it into linear factors. So we'll factor this and see what we get. So 2x and x would multiply to 2x squared. 15 could be 3 and 5. This would be 3x and 10x, which won't really add up to just x. So let's switch those. So 5 and 3. So now we have 5x and 6x, which can add to positive x if the 6x is positive. So that means f of x can be written as, if I take this 0 and turn it into a factor, it would be x minus 2. And then these other factors, 2x minus 5 and x plus 3. Let's do the next one. So we have -4 is a known 0, and we want to factor the polynomial that's given. So we'll get started by factoring out that 0 using synthetic division. So we'll bring 6 down. 6 times -4 is -24, so that column will add up to 1. 4 times 1 is -4. These two add up to -1. -4 times -1 is +4, so this last column results in 0. So that means I have coefficients here of the remaining quadratic being 6x squared plus x minus 1. And all I need to do now is to factor it. So two things that would multiply to 6x squared would be 2x and 3x. And for 1, that's just 1 and 1. All right, so if I have 3x and 2x, I can get those to add to positive x if the 3x is positive and the 2x is negative. So that means my polynomial now looks like, if I take this value right here and write it as a factor, it would look like x plus 4. And then I have 2x plus 1 and 3x minus 1. And so that's an equivalent polynomial, but in factored form. Lastly, I have f of x equals x to the 4th plus 2x cubed minus 7x squared minus 20x minus 12. And then I'm told that k is equal to -2 is a 0, but of multiplicity 2. So what that means is I can actually factor it out of the polynomial twice. So let me show you how that works. So I'll take -2 out of the original polynomial. All right, bring the 1 down. 2 times negative 2 times 1 is negative 2. That column adds to 0. So anything times 0 is 0, so this becomes negative 7. That would add up to positive, or multiply to positive 14. This column would add to negative 6. Negative 2 times negative 6 is positive 12, so the result is 0. Now, because this is a 0 of multiplicity 2, it's a 0 twice, which means I can take this resulting polynomial, which is 1 degree less than the original, so this is now a degree 3, and I can factor it out of that degree 3 polynomial. So bring the 1 down. Negative 2 times 1 is negative 2. That adds up to negative 2. These multiply to 4, and that column will add to negative 3. Negative 2 times negative 3 is positive 6, so the result there is 0 again. Which means I now have the resulting quadratic of x squared minus 2x minus 3. And if I factor this, I'll now have the entire polynomial factored. So x and x, 3 and 1. If the 3 is negative and the 1 is positive, that will work great. And my polynomial here will look like k equals negative 2 changes into the factor x plus 2. And then the next factor is also x plus 2. So instead of writing it twice, we'll just use an exponent of 2. So anytime you have a 0 of multiplicity 2, it would have an exponent of 2 on that factor, that is. Then we have x minus 3 and x plus 1. And that's the final factored form.